Let's go and explore and understand greedy approach. So I hope you are very well versed with random exploration, because we would be, kind of using a lot of concepts here. In case if you are not, I would highly recommend you to watch this part of the series where we understand all the entire, reinforcement learning concepts and how you explore randomly. Now we will use the same concepts that we used in explore randomly. However, as we talked, the way greedy works is that it will want to pick the one which has given it the most of the, it is which is basically the best out of all. So if we go to the readme, always capture the one which seems to be most promising once all exploration is done. This is very important line, because how do you know which one is the most promising if you haven't explored all of them, right? So we want to make sure that all exploration is done, and that is what we will be doing here. So we have these things, rewards and all. Let me get rid of it. Okay. So rewards would be the same, visits would be the same. This looping logic will be different, and the results part would be the same. Only the looping logic we need to write. And we have added couple of things like minimum np.min. So basically np-min, because so from numpy we are importing minimum as np-min, which basically gives you the minimum of all the objects. Okay. So let's name it to explore greedy. And I will add one more parameter here called epsilon. Okay, so I will talk about it later, but the idea of the epsilon is for epsilon greedy approach. So in greedy we try to exploit everything that we know. We will make sure that we know this particular arm is giving us reward, so we will try to focus on pulling that arm again and again until its rewards falls down from the other arms. Like that we will keep on going. Okay. However, in case of epsilon, what happens is that because this world is dynamic, right? I mean, any situation is not very deterministic. We have a lot of dynamic scenarios. And so there is always a scope of exploration. Whatever you know today might be outdated tomorrow due to the, tomorrow's development and all. So for that, we give a factor of exploration every time. Okay. So let's move forward. So for underscore in range iterations, so we will run on how many ever iteration we are provided with. We will select, okay, so there is two condition. Condition one, we need to make sure all arms are visited. Okay. Based on this, if all arms are visited, so we will say if all arms are visited, implement implement the greedy approach or greedy strategy, as Copilot is saying, else pick arm randomly. Okay, so this is two things. So we need to make sure all arms are visited. So if, how do we know that? We can just do if np-min of visits is greater than 0. Okay, so what does this mean? So let's say initially we will have it something like that, where each index corresponds to an arm ID and each value would correspond to number of visits. If initially everything would be 0, but as we go on, this will be updated, and let's say first is visited, so first will become 1 and 0, and let's say this particular one is visited 5 times and so on. Okay, so if we actually have everything greater than 0, that is minimum of all these arms is greater than 0, then that means that every arm is actually visited once. Okay, so that is the logic. Okay, and here we will do arm ID equal to argmax of rewards. Okay, now what does this line mean? So let's say we visited this arm, we will, when we do the visiting, we need to update the rewards associated with that arm and the visits, basically visit count to that arm. Okay. Now when we see arm ID equal to argmax of rewards, it means that let's say if we have rewards like this 2.2, let's say 8.7, let's say 0.33 and so on. Okay, so if we say it like this, that means we are picking the maximum of this. So in this case, this is the maximum 8.7. So argmax will basically not return 8. If we do max of this, it will return 8.7. However, if we do argmax, it will return us the index. And what is index corresponding to? As we know, index is corresponding to the arm ID. Okay, so that is the plan. So when we use this argmax, we will get the maximum index, I mean a reward index corresponding to the maximum reward. Okay, I hope that makes sense. So in this case, let me make it shorter so that you can understand it better. 9 33 2. Okay, so in this case, if I do max, let's say this is rewards. Okay, so if I do max of rewards, it will return me 33 because that is the maximum. But if I do argmax of rewards, it will return me 1, because the first index is 0, second index is 1, and this is 2. So it will return me the corresponding index of the maximum element, which is 1. Okay, so arm id equal to argmax of rewards. Okay, now we will calculate the reward. So new reward equals to actually, I think if we calculate just the arm ID, we can then use it commonly. I guess that will make sense. Okay, and else if it is not, I mean, if all arms are not visited, then we need to do arm ID equal to random dot rand int of 0 till env dot total underscore arms. I guess that is the one. Okay, so this will make sure that we will pick the arm ID randomly if all arms are not visited. Okay, now we know the arm ID, so we will compute the and I think this else pick randomly, this should come up here. Yep. Okay, now since we know the arm ID, what we need to do is we need to just compute the new reward equal to env dot compute reward where arm id equals to arm id. Okay, so this will give us the reward corresponding with the arm id we have chosen. Okay, now we will increase the visits also. So we need to update two things, visits and rewards. So visits of arm underscore id plus equals to 1, which basically increments it by 1. Okay, and then rewards. So for rewards, we have new reward. We also need to know existing reward. So existing reward equal to rewards of arm underscore id, and then we need to update rewards of arm underscore id equal to new reward plus what existing reward. Yeah, so this is a basic formula. If I'll show you what this means. Existing rewards minus new reward divided by total visits. So let me create another visit. Total visits for equal to visits of arm id. Okay, so this is the formula. So the way it will work is, let's say initially we have arm id as reward 1. Okay, this is rewards array, by the way. Okay, and let's say visits is maybe again 1. Okay, so once we do it again, let's say this time we got new reward as 0. So new reward, let me move it to the downwards. New reward is 0. So the updated reward would be new reward, which is 0, plus existing reward 1 minus new reward 0 divided by 1 plus 1, which is 2. Okay, so this will give me 0.5, and so on. We keep on iterating and this keeps on updating. Okay, so this is the concept of what do I say, greedy approach. Okay, so if we already know that all visits are done, then we will keep on picking the maximum, the most promising arm until this reward gets below some other reward, and we will keep on doing this in case of greedy approach. Okay, and then we can rest all things are same. So result equal to empty array for index comma reward in enumerate rewards. We will append the index which is corresponding to the arm id and its respective reward. Okay, so let me run this one and let me try to for now epsilon has no role, so let me run this. So you can see that how these arm rewards have been updating through over the iterations. If we increase the number of iterations, it will further be saturated and so on. Okay, now what is the problem with this approach? this basically, once all the arms are visited, it will keep pulling the arm which gives it the maximum rewards, which is something that we don't want. Okay, we want to, I mean, that is fine in a deterministic environment where we know that whatever is today will be tomorrow also, everything will be similar, but that's not the case always, right? Our environment also keeps changing, so we always need a factor of exploration, and that factor of exploration is nothing but epsilon. Okay, whatever we specify here, like let's say if I do 0.1, so what this means is that out of 100, like 0.1 is basically 10%, so out of 100 times, 90 times you exploit what you already know, but 10 times you keep it for the exploration. So you try some random action and see how does that, how the rewards change and so on. So that is what epsilon is about. So let me just introduce it. So in case you see, if all arms are visited, implement the greedy strategy. This is the case of a normal greedy. Now how does the epsilon greedy work? If all arms are visited and probability, epsilon is greater than random probability. Okay, if these two are true, then implement the greedy strategy. Okay, so what this means is that, okay, we know all arms are visited, but do we also need to confirm that epsilon is greater than the random, we generate a random probability between 0 to 1 by using random.random. If this random.random value is less than, actually it's greater than the epsilon, which means that epsilon is less than the random probability, so we would again exploit. However, if epsilon is greater than this, then it will go to else block. So what we need to do is we need to just add an AND statement, and we need to do random.random. I hope that you are getting what we are doing here. So we are saying that, okay, this is an exploration coefficient. If exploration coefficient is greater than random, then again go for exploration. If not, then keep reusing the greedy policy. Okay, so this is what it is about, and let me rerun it. So this is the only change that you need to do when implementing epsilon greedy, making a greedy approach epsilon greedy. Okay, and we will see a lot of differences in result. We will be plotting these things to see how it is. Okay, so this is about explore epsilon greedy and with epsilon. If we don't provide it initially, I think it should be 0.0. However, if we pass this one, because if 0.0, that means it will always random.random will always be greater than this number, so that is fine. However, if it is less than, if we provide some value, then there is a good chance, like 10% of the time, this is going to be violated, and it will go to else block. So that is the concept. So now next we will see how upper confidence bound works. Okay, thank you.